Hi all, I am here with my new video on chemical periodicity. Let's start. In this video, we are going to learn about the chemistry of the representative groups. Group 1, Alkali Metals. The elements in the group 1 is called Alkali Metals. Characteristics of this group are as following. Have valence electron 1, metallic, low first ionization energy. Alkali metals have the largest atoms in their period. Low electronegativity, form +1 ions, highly reactive, do not occur as free elements in the nature and must be prepared by passing an electric current through their molten compounds. Group 2, Alkaline Earth Metals. The elements in the group 2 are known as the Alkaline Earth Metals. They have following properties. Each element has 2 valence electrons, less metallic character than alkali metals, form +2 ions, although beryllium Be, which is relatively small, is known to form covalent bond with elements such as chlorine, reactive and do not occur as free elements in the nature. Special properties of hydrogen. Hydrogen is not considered an alkali metal because its properties are not similar to those of the other elements in the group 1. This exception is due to the small size of the hydrogen atom and the large attraction of the nucleus for the single electron. Hydrogen is associated with group 1 because it has 1 valence electrons like other elements in the group. Group 13. In group 13, elements have 3 valence electrons, forms +3 ions. Boron, first element of this group, is a metalloid. Boron does not form +3 ion readily because of its small size. Group 14. Elements in group 14 have 4 valence electrons. Carbon is a nonmetal and occurs in 2 crystalline forms, graphite and diamonds. Silicon and germanium are metalloids that are used widely in the computer industry. Tin and lead are typical metallic substances. Group 15. Elements in this group have 5 valence electrons. Nitrogen, first element of the group, exists as a diatomic molecule N2 in nature. Nitrogen is relatively inactive because of its triple bond between two nitrogen atoms, which needed higher energy to break it. Phosphorus is a non-metal, exists in two allotropic forms, red and white. Group 16. Elements in this group have 6 valence electrons. Oxygen, a non-metal, exists in nature in two allotropic forms, oxygen and ozone. It readily forms 2- ion. Sulfur is also a non-metal. It exists in several allotropic forms and can form 2- ion, but it is less reactive than oxygen. Selenium and tellurium are metalloids. Polonium is considered a metal. Group 17 elements are known as halogens, 7 valence electrons, form 1- ions. Most reactive of the non-metallic elements with fluorine is most reactive. Fluorine and chlorine are gases at room temperature, bromine is liquid, and iodine is solid. Halogens do not occur as free elements in the nature. Group 18, noble gases. In this group, elements are noble gases, have 8 valence electrons except helium. Helium has 2 valence electrons. It is associated with this group because its properties matches with those of other elements. Extremely stable, occurred as monoatomic gases in the nature, do not combine with others readily, but compounds of krypton and xenon have been prepared. The transition elements. Characteristics of the transition elements are as following. Begins in period 4 and includes group 3 to 11. Transition elements have multiple oxidation states because the two outermost levels may be involved in chemical combinations. The ions of transition elements are usually colored both in aqueous solution and as solids. Sublevels and the periodic table. S block. Group 1 and 2 constitute the S block because within these two adjacent groups, the S sublevels are filled. P block. Group 13 to 18 constitute the P block because within these 6 adjacent groups, the P sublevels are filled. These S and P blocks are called the representative elements. D block. The D sublevels fill in groups 3 to 12. The D block is called the transition elements. F block. In the two separated rows of the bottom of the table, F sublevels are filled and they are called F block. The F block is called the lanthanide and actinide series. Naming newly discovered elements. When a new element is discovered, it is given a temporary Latin name and a three-letter symbol that is related to its atomic number. For example, when flerovium Fl114 was discovered, it was assigned the temporary name ununquardium, symbol UUQ. Each letter of the symbol corresponds to a digit in the element's atomic number. U is equal to 1, U is equal to 1, Q is equal to 4. Each letter has a Latin root and these roots are joined to form the element's temporary name, ununquardium. The accompanying table on the next slide lists Latin roots and the symbol corresponding to each digit from 0 to 9. As usual, the first letter in the three-letter symbol is capitalized. Table with Latin roots and the symbols. Digit 0, root nil, symbol small n. Digit 1, root un, symbol small u. Digit 2, root bi, symbol small b. Digit 3, root tri, symbol small t. Digit 4, root quad, symbol small q. Digit 5, root pant, symbol small p. Digit 6, root hex, symbol small h. Digit 7, root sept, symbol small s. Digit 8, root oct, symbol small o. Digit 9, root n, symbol small e. Synthetic elements. A number of elements do not occur in nature. These synthetic elements include technetium, Tc atomic number 43, and all of the elements with atomic numbers larger than 92, the transuranium elements, all of which are radioactive. Technetium was the first element to be produced artificially by bombardment, and it is also found as a byproduct of fission reactors. Transuranium elements are also produced by bombardment reactions. The largest element discovered to date is ognation with an atomic number of 118.